Greetings to you once again. Star e-learning platform welcomes you to another lesson, and this is a chemistry lesson. We are handling the senior 3 and senior 4 students as they prepare for their exams and prepare to do well in their academics. We prepare such lessons to guide them and provide them with the necessary information that could enable them perform better. This is teacher Kadu Deogracious. You can always reach us using this telephone number. In case you have any inquiries or any questions about our lessons, please use this telephone number and connect with us. It is connected on WhatsApp. You can always inbox us on WhatsApp. We shall readily respond to you. If you have any question about our lessons, you have any inquiries about our services, use that telephone number to connect with us. Before we start our lesson today, I want to request you one thing. Please subscribe to our YouTube channel. Our YouTube channel name is Star e-learning platform e-class. Please, as you view and watch these presentations, try to give us that little support by subscribing. Subscribe to our YouTube channel. God will bless you. I want to thank you in advance because I believe you're going to do it. In our lesson today, we are still looking at energy changes, and this is my 63 lesson on energy changes. So in today's lesson, we are going to look at enthalpy or heat of solution. Now, all of us, we know that water is a universal solvent, and when substances interact with water, they happen to dissolve in water. And when they do so, there are some changes, like some heat changes. Some may dissolve by absorbing heat energy, while others may dissolve by releasing heat energy. Now, when salts, of course, those are compounds. When salts dissolve in water, the process may be exothermic. When you talk of exothermic here, we mean that such salts may dissolve by releasing heat energy to the surrounding. Or that process may be endothermic, which means the process of dissolving such salts involves absorption of heat energy from the surrounding. Now, some substances dissolve by releasing heat energy, as we have so far seen, and therefore the temperature of the solution has to increase. So if heat energy is released to the surrounding, the temperature of the solution and that of the surrounding increases. For example, we can look at a typical example, that is calcium chloride. If you dissolve calcium chloride in water, the reaction is exothermic. The reaction is what? It is exothermic because, in fact, it is not necessarily a reaction, but it is a process. So the process is exothermic simply because it occurs by releasing heat energy. When you look at calcium chloride closely, when dissolved in water, it produces a drastic amount of heat. You may see even temperature changing from a certain degrees to 60 degrees Celsius. The change may be to 60 degrees Celsius. So if you happen to eat it, this calcium chloride is going to burn you because it will have to interact with the water within your saliva, and when dissolving tries to take place, it will end up burning you. So such substances which dissolve by releasing heat energy, they dissolve exothermically. Hope you are together. Now others dissolve by absorbing heat energy. Others dissolve by absorbing heat energy. And the temperature of the solution and that of the surrounding happen to drop or happen to fall down. The temperature of the surrounding and the solution happen to fall down. An example is sodium thiosulfate and ammonium nitrate. Those two compounds, when dissolved in water, they take away or they absorb heat energy from the surrounding. and therefore sodium thiosulfate and ammonium nitrate dissolve endothermically. They dissolve what? Endothermically. In fact, if you try to dissolve a compound like sodium thiosulfate in water, you're going to see that the temperature is going to fall down. It can even fall down to temperatures below 0 degrees Celsius. If you are dissolving sodium thiosulfate in water, the solution can even change to ice to show you that there is all the heat that is in the solution is being absorbed or is taken away during the process. So such substances which dissolve by absorbing heat energy from the surrounding, such processes take place endothermically. So that is a brief introduction we can look at. So now let us look at that heat of solution, or that heat enthalpy of solution. Now, what is meant by heat of solution? What is meant by heat of solution? So far we have seen that some substances dissolve in water by releasing heat energy, while others dissolve in water by absorbing heat energy. Hope you get me there. So now we want to get a definition from that. So now what do we mean by heat of solution? Heat of solution here simply means the enthalpy of solution. The amount of heat is the amount of heat. The heat of solution, or enthalpy of solution, is the amount of heat given out or released or absorbed when 1 mole of a compound dissolves completely in water to form an infinitely dilute solution. I repeat, a definition for heat of solution is the heat of solution is the amount of heat given out or absorbed when 1 mole of a compound dissolves completely in water to form an infinitely dilute solution. So what is an infinitely dilute solution? An infinitely dilute solution is a solution where any addition of the solvent to it will not change the concentration of the solute in that solution. So at such a state, some heat might be produced or might be absorbed. So therefore we are saying that the heat of solution is simply the amount of heat either given out or absorbed when 1 mole of a compound dissolves completely in water to form an infinitely dilute solution at a state where any addition of a solvent does not change the concentration of the solute. Okay, now this enthalpy change, it may be positive, meaning that the enthalpy change or the heat change might be endothermic. In other words, the process might take place by absorbing heat energy from the surrounding, and therefore it is assigned a positive sign. A positive sign is representing an endothermic process. In this case of dissolving substances, we don't talk of a reaction because it is just a process where particles are broken free and some heat energy might be released or absorbed. But in this case, we are talking about heat energy being absorbed, and we assign it a positive sign. So if substances dissolve by releasing heat energy, then the heat change is going to be assigned a negative sign. And therefore the reaction is, the process is going to be exothermic. Okay, the units for heat of solution are kilojoules per mole. The units for heat of solution are kilojoules per mole. So heat of solution is expressed in kilojoules per mole, or it can be in joules per mole. Of course, if the reaction is exothermic, you include a positive sign. If the reaction is endothermic, we could include a positive sign. If the reaction is exothermic, we include a negative sign. A negative sign when it is exothermic, a positive sign when it is endothermic. Hope you are together. Which means that for every 1 mole of a compound that is dissolved in water, that amount of heat, or X kilojoules of heat, are absorbed, or they can be released. So if they tell you to explain what may be negative X kilojoules mean, of course you know how to, of course per mole, you will know what it means. Here it means that for every 1 mole of a substance dissolved, this amount of heat is released, since it is an exothermic reaction. If it is positive, like this, it will mean that for every 1 mole of the substance dissolved, this amount of heat is absorbed, and that's why it is given a positive sign. Okay, hope that is clear. Let's continue. Now let us look at calculations on molar enthalpy of solution. They are telling us that 80 grams of ammonium nitrate were dissolved in 92 cubic centimeters of water at 20 degrees Celsius. At 20 degrees Celsius, and the final steady temperature of the solution was 14 degrees Celsius. The question is asking us that what does the drop in temperature indicate about this process? The temperature is dropping from 20 to 14. So what does it indicate? If there is a drop in temperature, what does it indicate? Here it indicates that the reaction occurs, the process is endothermic. It means the process takes place endothermically. In other words, there is absorption of heat energy. Of course, we know temperature is a measure of heat energy. So if there is reduction in temperature, it means there is also reduction in heat energy. Therefore, heat energy is being absorbed or taken away from the surrounding or from the solution. So therefore, the reaction occurs endothermically. So if we come back to our answer here, we shall say that it indicates that ammonium nitrate dissolves by an endothermic process. Hope you get me there. Now we come to part B. Part B is asking us to calculate the heat of solution of ammonium nitrate. Of course, the heat of solution of ammonium nitrate is going to require us to use 3 steps. As we saw earlier, when we are dealing with the enthalpy of neutralization, we looked at 3 steps. So even here, we are going to apply 3 steps. The first step, we shall have to calculate the heat energy absorbed. In this case, there is some heat energy absorbed. So we shall first calculate that heat energy that is absorbed. Then secondly, we shall calculate the number of moles of ammonium nitrate that is dissolved. Then finally, we can calculate the number of moles, the amount of heat produced by 1 mole of ammonium nitrate. Of course, the amount of heat we are going to calculate is representing those number of moles that reacted. In other words, the number of moles which were dissolved are going to produce that amount of energy that we are going to calculate. So let us look at those 3 steps and we'll see how we can apply them. Now I said we are going to start with calculating the heat produced. Heat produced is calculated from this expression, that is mc dt, where m is the mass, c is specific heat capacity, dt is temperature. Do we know the mass? Since we have we have a mixture of 2 substances, we have ammonium nitrate and water. So we need to add the total mass of those substances. we need to add the total mass of the substances. Do we know the mass of ammonium nitrate? Yes, they gave us the mass of ammonium nitrate. It is 8. It is 80 grams. Do we know the mass of water? No, but we can calculate it. We can calculate it from the expression for mass, which is density times volume. Do we know the density for water? Yes, it is 1 gram per cubic centimeters. So if we try to insert in our formula, we have our density and the volume. So cubic centimeters are going to cross with the cubic centimeters. They are going to cross and we remain with this one. If you try to compute, we shall get 92 grams. So mass of water is 92 grams. So therefore, our total mass here becomes 80 grams plus 92 grams, where we are going to get 100 grams. So the total mass of the solution that was mixed, that was containing ammonium nitrate is 100 grams. Now we have got the mass. Do we know the specific heat capacity? Yes. Since this is a solution, a dilute solution containing water, the specific heat capacity of that solution is equal to that of water, which is 4.2 joules per Kelvin per gram. Do we know the temperature change? We can calculate the temperature change, which is 20 minus 14. We end up getting 6 Kelvin or 60 degrees Celsius. Hope you're together. Now you can insert in your formula here. When we insert in our formula there, we have our mass, 100 grams, the specific heat capacity, and the temperature change. If we insert in our formula, we are going to come to this. Hope you're together. Now Kelvin, we have to cancel with Kelvin, grams with grams, and we come to this one. If we try to compute, we shall come up with 2520 joules. So therefore, we have calculated our heat produced. So when ammonium nitrate dissolves in water, it absorbs this amount of heat. We are saying absorbing simply because there was a drop in temperature. So the process occurs by absorbing heat energy, this amount of energy. This amount of energy was absorbed. Hope you get me there. So we are dealing with the heat absorbed, not heat released or produced. It is heat absorbed. Reason being, the reaction occurred by a drop in temperature. There was a drop or a fall in temperature. Okay, let's continue. Now, our next step, we said we must calculate the number of moles of ammonium nitrate that dissolved. But if they have given us mass in grams and they want us to calculate the number of moles, then in any case, we need to use the relative formula mass of ammonium nitrate. And for us to calculate the the relative formula mass of ammonium nitrate, we should know the formula for ammonium nitrate, which is that. So we use it to calculate the relative formula mass. So if you try to calculate, we are going to get our relative formula mass as 80, which means that 1 mole of ammonium nitrate weighs 80 grams. Then what about 80 grams? So it is going to be just a matter of cross multiplying. We shall have 8 times 1 divided by 80. We come to that. Hope you're together. So that means that we have, if we try to compute, we come to 0.1 mole. So therefore 0.1 mole of ammonium nitrate contains those number of grams, which means the amount of ammonia, the number of moles of ammonium nitrate that were dissolved or that was dissolved was 0.1. So those are the number of moles of ammonium nitrate that were dissolved in water. So after calculating that, now we are good to go and get the molar enthalpy of solution. So now we can calculate the molar enthalpy of solution. Of course, this amount of energy we have calculated here, the amount of energy we calculated and the number of moles we have calculated, they are matching. In other words, this number of moles we have calculated absorbed this amount of heat. The number of moles that we have calculated absorbed this amount of heat. Hope you get me there. Now what about 1 mole? Because our concern is about 1 mole, since we are talking about the molar enthalpy. What about 1 mole? 1 mole will be 1 times that divided by that. And we come to that. If you try to compute, we shall come to that. So therefore, 1 mole of ammonium nitrate absorbs 25,200 joules of heat. Now, I think we know that the reaction occurred by a fall in temperature. There was a drop in temperature. So if there is a drop in temperature, it means the process or the reaction is endothermic. So therefore, since the reaction is endothermic, then we shall have to assign it a positive sign. So that's why we give it a positive sign, meaning that for every 1 mole of ammonium nitrate, for every 1 mole of ammonium nitrate that dissolves, this amount of heat is absorbed. So that's why we assign it with a positive sign. If you want to convert to kilojoules, it is a matter of dividing by 1,000 and we get that. Okay, let's look at enthalpy of displacement. Hope you studied about the reactivity series of elements, and your teachers must have taught you those elements that are less reactive and those elements that are most reactive. Elements that are very reactive, for example, potassium, sodium, calcium, those elements, when mixed with solutions of elements that are less reactive, for example, copper sulfate. If you mix copper sulfate with a copper sulfate solution with sodium metal, the reaction is going to be exothermic and copper is going to be displaced from its solution. It is going to move away from the solution and we form now a copper metal. It is going to be displaced from the solution and we form copper metal. The reason being that sodium is more reactive than copper. Similarly, if you mix copper to sulfate solution with the potassium, the reaction is going to be violent. So potassium is going to displace copper from its solution, and therefore we shall have copper metal, and then we have copper sulfate, potassium sulfate as a new solution. So now we come to this term of enthalpy of displacement. So when substances are displaced from their solution, there is some heat energy produced. So that heat energy that is produced when substances are displaced from their solutions, we call it enthalpy of displacement. So therefore we can come to this definition and we say that enthalpy of displacement is the enthalpy change that occurs when 1 mole of a substance in a solution form is completely displaced by another, and that another substance must be more reactive than it. Hope you get me there. So a less reactive substance cannot displace a substance that is more reactive. It is those that are more reactive that displace the ones that are less reactive. So therefore, less reactive particles or substances are always displaced by more reactive particles. I've given you an example between copper to sulfate solution and potassium metal. if you mix the two, potassium is going to go into the solution and copper moves out of the solution, and the reaction is exothermic. So that heat energy, that is that heat change that occurs when a substance is displaced from its solution, we call it the heat of displacement. Hope you get me there. So now this one marks the end of our energy changes theory. In our next lesson, we shall be handling the practical application of energy changes. We shall look at energy changes in terms of practical, and we see how practically we can apply heat changes. So that is all that I had prepared for you. Thank you for viewing my lessons. Thank you for subscribing, those who have subscribed. I continue to request those who have not yet subscribed to please do so. We need your support, and that support we need is from your subscription. Thank you so much for listening to me. We meet in the next lesson. God bless you.